Hi, good morning, students. So we'll be starting the session soon. So kindly ask your friends to join the session quickly. Others, just let me know like when exactly we can start the session.
Tawfiq, let's wait for 5 more minutes and then we can start.
Sure.
Tofik, you can start the session now.
Hi, good morning, everyone. So, I believe my voice is clear and good. Can I get the confirmation in the chat box? Yeah, very good morning, Ashit. Yeah, very good morning to everyone. Okay, so if you remember, last week we had a discussion on PyTorch, then we started with generative AI as well, right? So, Adarji, do I need to record or you'll be recording the session?
Tofik, you can record the session.
Okay.
Recording in progress.
Right. Okay. So as we had a discussion last week, we just started with PyTorch. We understood like how to convert into tensors, then how exactly we used uh, the linear regression model by using PyTorch, right? And I had also told you that in upcoming session we'll be working on CNN model as well. Okay, so I'm not gonna dive too deep inside the CNN because you have already covered up the CNN algorithms, convolutional neural network. I think Piyush sir had explained you about how exactly CNN works. He might have explained what is pooling, padding, etc. Yes? Can I get the confirmation? I believe everyone is aware about pooling, padding, etc. Matrix calculation, it might be about the pixels and all, right? Okay. So let me just show you one of the experiment where we are using PyTorch. Okay, previously we did not use PyTorch, right? So I'm using the framework PyTorch as of now, and by using that PyTorch framework, what we'll be doing, we'll just do the image classification. Okay, so before that, let me just share the screen as well. Right. Yes. Is my screen visible for everyone? See, as I've already told that we are not going too technical here uh, because already we have covered a lot of what we can say uh, the things which comes under CNN, or you can also call it as the neural networks, right? Okay. Directly, let us talk about the problem statement. The problem statement is very simple. Okay. Image classification using CNN in PyTorch. Okay. Previously, we were only working with CNN, but not in PyTorch. PyTorch is another framework where we convert a certain image into the tensors, if you remember that. Okay. All right. Okay. Now, in this certain tutorial, what I'm doing is I'm just taking the CIFAR10 dataset. So, how many of you have already worked in CIFAR10 dataset? Can I just get the confirmation? CIFAR10 dataset. How many of you have used CIFAR10 dataset earlier? Okay. So a lot of people are telling that you haven't used, not a problem. So I'll be sharing the same exact file with you people. Okay. So once let me complete this entire session, then later on I'll be sharing this file with you people. So that after this, like we had left out with generative AI part as well in the last week. So we're gonna have a continuation of that one as well. Okay, so basically this is nothing but a data set which is containing with 10 different what we tell images. Okay, so images are like images, automobiles, it is related to bird, cat, deer, dog, frog, horse, ship, and a truck. Okay, so there are 10 different classes over here, you can, as you can see in the screen. Okay, and now it is having 60,000 images. Okay, the data set is containing 60,000 images and the pixel of 32 into 32, the size of the image. Okay, 32 into 32, px stands for nothing but the pixels. These are the sample images. Okay. So basically, if you try to load this data set, you'll be able to work on this. Okay. Now, in order to work on the project, let me just import few libraries here. I'm not going to execute the functions here. Rather, I'll be showing the code what I am using. Okay, I'm just importing the operating system here. Likewise, we had used the Torch library, PyTorch, right? So in order to use PyTorch, so I'll be using the Torch as a library. Now I'm using Torch Vision. So can I get the confirmation like why exactly we are using Torch Vision and why not only the Torch? What might be the major difference here? Yes, I'll be sharing the file. After the session is being completed, I'll be sharing the file. The file I'll be sharing, no need to worry. Please, as of now, focus on the code cell now. Can you give me the major difference between the Torch and Torch Vision? What might be it? Torch and Torch Vision. Okay, Perth is telling that image recognition. Okay. What about, see, I want one of the major reason. Torch Vision is used for image transformation. Okay. Okay, so see here, the major thing is whenever we are using tensors or the torch, okay, so it is one of the main library of the PyTorch, but we can only work on like the tensor operations, like either we can just work on NumPy or different other the tensors we can tell. Okay, so we can also optimize it, we can just train the models, but when it comes for Torch Vision, majorly it is working on the image datasets in order to work on the images. Okay, it can also have the accessibility of the pre-trained models. Okay, image transformations. Okay, these are the things. Okay, so again, there are few models which are already inbuilt in the Torch Vision. If you might have heard about ResNet or AlexNet, okay, so these are already pre-trained models in the Torch Vision. If you are aware about these things, you can definitely use this. Okay, then again, there is another import function what I'm using here called as tar file. Can anyone tell me about the tar file here? Yes, I'm getting the response, but I want few more things from your side as well. Tar file. What might be this tar file is? Uh, Browse the files for browsing the files. Okay. Any other things? Yes, you're almost right for file handling. Okay, you might have seen that like if there is a data set which is quite very big, the extension is different. You might have seen that the extension will be like .tar or .tar.gz or tgz or tar or something. Different files will be there. Okay, so in order to extract those things, okay, what we will be using, we will be using the tar file here. Okay, so just have a look in the same code cell only. Okay, so over here, like I have taken a variable dataset URL and I have provided a link where all the images are available, right? So just have a look. Okay, let me just copy and paste it. If I just copy and paste it, directly the file will be downloaded. Okay, so this is a dataset link where I can just directly uh, download the dataset, the CFAR dataset. Okay, now in the CFAR dataset, you can just have a look. The file name is in the image classification, it is telling that CFAR 10 dot TGZ. So TGZ is nothing but the extension what we are using. Okay. Now why we are using this? In order to extract the data. The data set is very huge. Okay, this data set is very big. It is containing 60,000 images. Okay, so what the 60,000 images, if I'm just using tar file, basically it will what compress the size of the data. Okay, majorly used for compressing, or you can also call it as for faster download and for storage efficiency also. Okay, so majorly we are compressing the things, that's it. We have the data will not be lost. Rather, what happens here, if there is a big file, if I'm using tgz or .tar or something, okay, it's gonna be compressed. Okay, so in order to extract the data set easily, we'll be using this. Okay, so in dataset URL, I've passed the path, and here I'm just using a function download URL and the URL link here. And just have a look, the code cell got executed, and we are getting the downloaded link over here. Okay. Now, how to extract the file? I've told that I'm just compressing that one, right? Now, after compressing, how to extract this? So I'll be using a keyword called with. Okay. Now, with is a keyword where I'm just working with the files now. Okay. And what kind of a file it is? It is nothing but cfr.tgz, and I'm just giving the mode as R. See here, when I'm using the function in order to work with a certain file, I can work with any kind of file, whether it might be CSV, or whether it might be the what Excel file, or whether it might be any different files as well. So what I'm just doing, I'm just opening the file with the help of with keyword. Okay. So here I'm just using with, and I'm trying to use the tar file and open that cfr file over here. And what exactly I'm just giving? I'm just giving a keyword called R. That means I want in the read mode. Okay. So there are different keywords or parameters, we can tell what we'll be using in order to work with the with keyword. That means R for reading, W for writing, right? A for appending the images, etc. A lot of things can be done over here, but I'm just using the R. Okay, and then I'm extracting all the things. Okay, so once the extraction is being done, okay, now you can just check like what are the different things are available now in. Okay, let me just try to run and execute this. That would be the best idea, I guess. Let me first execute this. Now the project name I'm giving as project cfr10 cnn. First, I'm importing all the libraries: operating system, torch vision, tar file. Okay, then to download the data set. Okay, then the random split from the data. Right. Okay, then let me just download the data set here. As you can see that almost it is containing somewhere around 49.9 MB. This is the size of the data set. Okay, then I'm extracting the images here. Right. Okay. Now, all the documentation also we have written in the text here. Okay, you can just have a look. The things what we have mentioned here. The data set is extracted to the directory called data slash cfr10, where it is containing two folders. Okay. Now, in this data set, like I've already told, there are two folders. One is train and test. Okay, containing training data with 50,000 images and the testing with the 10,000 images respectively. There are two folders. Okay, one folder is containing for training data, and other folder is for the testing. Okay, now training images are 50,000 and testing images are 10,000. Okay, now again in that training folder there are 10 different other folders as well. Okay, so inside the training folder, again there are 10 different folders. You can just have a look, like the folder names are displayed here. Okay, so in the data directory I'm just listing all the different folders here. That is why I'm using operating system and to list all the directories inside the folder. there is a folder called train, right? So in the folder called train, I'm just extracting all the classes, what are the different things are available. From the CFR 10, there are two different classes of, sorry, folders, that is called as test and train. And from the training data, there are 10 different folders. All the folders are having their own individual images, like the images of dog, frog, ship, truck, deer, bird, horse, cat, automobile, and the airplane. Okay. So you can consider that if it is 50,000, 5,000 images are considered as a single class. Okay. So there is a class called dog, right? So for the dog class only, like there are 5,000 images. So if you calculate 5,000 into 10, that means it becomes 50,000. It is only for the training part. Okay. So I'm not using for the testing here, I'm just using for the train here. See, it's not only that you have to work on the train here, you can also check it with the test here. The same thing is available here. For the testing also, the same classes are available. I just change the code here. Okay, in the data directory, the CFART and the folder name. Okay, so inside that there are two folders, that is train and test. If you just interchange whether you want it for the test or if you want it for the train, and if you just execute, all the same classes are available, both train or the test. Is everyone clear till here? Any doubts still here? Students, I'm still expecting the things from you people. Right. It would be great if you just volunteer and ask few doubts as well. Okay. Right. Then, so this is all about our data sets. Okay. So in the documentation part also, you can see that we have highlighted a point. Look, let's look inside the couple of folders, and from the training data set, let's try to check the images. Okay. So what I'm just drawing is uh, basically you can have a look, like I'm just extracting one of the class called airplane here. Okay, so you can also cross check with other different class here. So here I have mentioned as airplane, right? So let me just make it as bird. There are different classes. Okay, so here what I'm doing, from the operating system, from the list of directory, there's a folder called train, and from there I'm just focusing only on the class called bird. Okay, then the print statement can be anything. So instead of airplanes, let me just make it as the bird here. Okay, and right, the certain variable name is same. I'm just sticking with the same thing. Okay, don't get confused here. So if I'm just executing here, like the names of the what images along with what is their extension is getting displayed. Like I've told, for bird there are total 5,000 images. This is the total length. That means how much exact images are pending. Okay, so out of that, like these are the different examples. Okay, so I can also use it for the opening the image as well. See, this I'm just displaying only the file names, right? 0533.png, 1926.png, right? So all the PNG extension, the image extensions are getting displayed here. Okay, likewise, I can just also do it for the testing here. For the train, I have used as bird, and for the what for testing, like I'm just using the ship images. Okay, so as you can see in the ship, there are 1,000 images. Okay, why it is 1,000 images? See again, like training data, we had 50,000 images, and testing data, we had only 10,000 images. Okay, so from the 10,000, if you consider that each class is having 1,000 images, that means it will be equivalent. 1,000 into 10 different classes, that is 10,000, and 5,000 into 10 different classes, that is 50,000. Okay, right. Okay, now it is telling that the above directory or the structure, the folder of the different classes, what we have seen is giving only the values. But now what if I need to convert a single image into the tensor? How can I do that? right? So if you remember that in previous session, like when we were discussing about the basics of PyTorch, I told you how to convert an certain array into the torch, sorry, into the tensor, not the torch. Torch is the library. An numpy array converted into the tensor. Okay. So likewise, we have to convert an image data as well into the tensors. Okay. Now, what kind of image it is? It is a colored image, if I believe. Okay. So what are the three different components will be coming in under the colored image? RGB with the three filters, right? Red, green, and blue. We can also call it as the channels, right? If you have gone through the physics concepts in physics, you might have learned about the different channels, RGB and all, right? So that is how we're gonna take it here. Okay, so we have the documentation which is already given. Let's look the sample element of the training data. Each element is a tuple and containing image tensor and a label. Since the data consists of 32 into 32 pixel images, I've already told in the beginning of the session that the size of the image is nothing but 32 cross 32, and it is a colored image with three channels, that is RGB, three channels, red, green, and blue. Okay, and for that, what we need to give the shape of it? Three channels with 32 into 32, that is the size what we are giving. So basically this is the shape, we can tell this is the shape we want to make it for a image in order to pre-process and in order to put this into the training part. Okay, so I'm just taking two variables here, image and label, and I'm just giving a data set of zero. Okay, what is this data set now? Now, this data set is nothing but all the training images, all the train images I have converted into tensor, to tensor. Just have a look here. Okay, so there are two libraries what I'm using. One is Torch Vision, and where I'm just using image folder. Okay, Torch Vision, where I'm transforming all the things into the tensor here. Okay, so I'm transferring or I'm transforming an image into the tensor value. Okay, so if I want to use that both the things, I'm using these two libraries now. Now the variable I'm using as dataset, and I'm using from image folder. I want to utilize one image folder. From the data of directory, I'm picking only the training data. And in the same thing, I've applied one parameter called transform equal to tensor. I want to convert that training data into the tensor now. Let me just execute this. Okay. And once I'm done with that, what I'm doing, I'm just creating uh, a here I'm just picking one certain image and I'm converting into the tensors now. Everything has been converted. Here it has been converted. Then I'm extracting uh, the values, a data set of zero, basically the first class, okay, where the size is 3 comma 32 comma 32, and these are the tensor values of every image of a class 1. Okay, then again, if you want to verify from the dataset classes, you can also verify the dataset variable what I had extracted. These are the classes, and index position 0 means basically these are the values of the airplanes. Okay, just have a look. I have given the index position as 0, dataset of the index position 0. Okay, the index position 0 basically means that all the airplane images I'm just displaying that. It's already converted into the tensor, but if I want to display it, I can just use that one, indexing method. It's not only that you want to work on only the index value 0, you can also check with the first uh, index position 1, basically the second class, that is nothing but automobile. Okay, then simultaneously you can check with other elements called as let me just check with 9. So this is the element, sorry, class 9. And what is that class 9? That's nothing but the truck here. Okay, so that is how you can just manually cross check each and everything. Okay, and again, if you just pass the okay, let me just, my mistake, right? That is how manually you can just cross check each and every element from here. from the data set. Okay. Then, so after getting all the different classes here, right? You can, if you want to plot the images, you can just use matplotlib in order to plot those images here. So I'm just importing matplotlib. Okay. Then if I want to what showcase an image, I need to define a function where I'm just extracting the images from the data set and the class what exactly I want. Okay. So let me just import matplotlib first. Now I have built a Python function in order to extract the image and to display it by using matplotlib here. Okay. Now show example is the function name. I'm taking two parameters. One is the image and the label. Okay. And I have passed as a form of dictionary so that it can show what kind of image it is. Okay. It is telling that it's nothing but the airplane here. So if you are good at Python functions, you might be aware how to use this again, right? Done. Okay, now let me just recall the function here. Show example is the function name. I'm using a data set of index position 0. Now this is the first image. So you can also change the value and cross check. Instead of 0, let me just pass the value called 5. Let's see. You can have a look. Similar to airplane only, right? See, again, I'm telling this, I'm using matplotlib. So the clarity is very minimal. Okay. You should be aware about that one as well. Let me make it as 400. There will be a different image now. This is also an airplane. Let me just make it as 5004. Yes, in 5004. See, after a certain element reaches, because I'm using the data set from the training data, right? So after 5000 images of the airplane, the other images of automobile, you can have a look. The label is coming as automobile here. You can cross verify uh, at the top only in the figure because I have given the label name here. Okay, you can make it as 10,004 and it is a bird. This is a second index position with a what with another different what we can tell class. Okay, right. Let me just make it as 0 only as of now. An airplane image. Okay. Then again, okay, we have tried multiple images here only. You can have a look like how these images are getting displayed. Right. Now, now let's come back to the training and validation data sets. Okay. Now we have three things: training, validation, and test. So can I just get the confirmation? What are the three major things here? Training, validation, and test. Why exactly we use this? Yes, Viral, I'll be sharing the notebook link like once I complete this entire session. No need to worry. Before the session ends, I'll be sharing in the same Zoom file. Yes. Can I get the confirmation now? Like, what are the three different major things? Why exactly we use training, validation, and test? See, in machine learning, you might have gone through these three things. Training, why exactly we use training data, why exactly we use validation, and why exactly we use test data, right? So training set basically stands for like when the data what we are using only for training the model, right? And yes, validation majorly for the adjusting the hyperparameters. Perfect, right? Hyperparameters in the sense like in order to improve like during the training phase after the training the model is being done. If you still need to adjust some hyperparameters in order to get the performance of the model very good, we'll be using validation. And what is this test? Test is simply nothing but like uh, in order to check with the real-time different values how exactly our model is behaving. Okay, right. Now, let's just start building the things now. Okay. So first what I'll do is I'll just create a random seed where I can just sorry, Viral, I didn't get your question. Test is interface. No, test. See, why exactly we use test? Because see, after our model training is being done, after validation is being done, if you just want to cross check onto the real time scenario how your model is working, in that time you'll be using the test. Okay, in some data sets you'll not be having the test data as well. In some data sets you will be having the test. Okay, majorly what we used to do is we used to take 60% of the data for the training. Okay, 20% of the data for the validation and rest 20% for the testing. Likewise you can split it, or else what you can do is 80% of the data for the training and 20% of the data for the testing. You can also go with these things. Okay, so it's totally your choice because you are working on the certain model. Okay, now so what I'm just doing, I'm just splitting all the data sets in order to work on the certain model here. Okay, so all the things you are aware how to split the data, right? How to take the training data, how to segregate the validation data. So I'm not gonna spend the time on this. Okay. Then from the utility of the data loader also, I'm just taking the batch size as 128 and applying some parameters here. Okay. The parameters are very simple. Already I have given the batch size as 128 for the training data, and here I've made it as shuffle. I'm shuffling all the images so that our model can have a better understanding about the images. And I'm also giving the pin memory. Okay, now if you are confused with few parametric functions, few parameters which you are not aware, you can just do some research on it, right? Right. Okay. Now from the torch vision, I'm importing the grid here. I'm creating the grid where I'm just displaying some image which you can see at the bottom. I'm defining a function where I'm just showing a certain batch. I'm just creating multiple batches, right? So in that batches, I'm just creating a grid image so that all the images can get included in a single uh, image with multiple different grids. Okay, so here I'm using subplots where multiple plots can be created. These are the different subplots, and the figure size 12,6. Okay, so this is the figure size what I'm just giving. The size of the image, you can also give it as a larger size if you want, whether it might be 10,5 or 10,20. It's totally your choice. Okay, right. Let me just execute this. Right. So I forgot to train one. Okay, here. Done. Right. Okay. Just have a look now. This is the grid image what I have created of. Okay. Okay. Now, convolutional neural network, you're already aware, so I'll not be explaining the stuff again and again because you have already gone through it. If you want, you can just refer to the CNN things what which had been explained earlier because we are focusing only on the PyTorch. So let's just come back to the PyTorch things here. Okay, so here what I'm just doing is I'm defining a function called apply kernel for an image plus the kernels. Okay, how many kernels we are using? Can anyone tell me here? How many kernels? How many kernels we are using? Okay, if there is the image, six. Are you sure, Jeet? No, it's not six. It is 3 cross 3. Okay. So you can just, if you are confused here, no need to worry. You can just revert back in the CNN concept and get to know about the kernels as well. Okay. So there will be three channels, right? In that three channels, RGB, there will be different kernels again. Kernel dimension is 3 cross 3. Okay, so let me just execute here. And those things, I'm just creating a sample torch tensors here. Okay, then later max pooling and all, I believe you're aware. Can I just get a confirmation what is a max pooling? How exactly this max pooling works? Consider this as a matrix. How exactly max pooling works? Max pooling. I think Piyush sir has already explained about CNN concepts, right? In the previous sessions. Yes. Then can you tell me how exactly this max pooling? Right. Yes. So in a certain what layers we can or we can tell as the pixels. Okay, it's gonna take up the maximum value of it. Like you can see there is 12, 28, and 12. So in this certain layer, whichever the maximum range will be there, that will be considered for the max pooling. Okay, so can you tell me what are the different pooling methods are there? Max pull, then average pooling is there, then average pooling, max pooling, then I'm still expecting the answers from you people. Yes, min pooling, min pool, right? So these are the different pooling methods what you are having. Some pool is also there. Yes. See, if I'm asking the question, you are just giving us the information. You are already aware, but you're not explaining or you're not just telling us back. Average pulling, global pulling, yes, yes, Viral. Okay, again, the some pulling, minimum pulling, all these things are there. Okay, each pulling method have their own different unique availability. Right. Now let's start with building the PyTorch model now. Okay, so likewise, what we had used for linear regression, will be using the same thing. Import torch.nn as nn. Okay, and import torch.nn functional as f. Okay, these are the two different uh, what import functions I'll be using. And I'm using a sequential model from NN. NN stands for neural network. Okay, from the torch library, I'm using the neural network architecture. I'm using the sequential model here. Okay, so I'm just building a simple model here. Just have a look. In the simple model, from the neural network of the torch library, I'm building a sequential model where I'm just giving the convolutional 2D layer. I'm just building a convolutional 2D layer first. Okay, where the size of 3 comma 8 is the kernel size of 3, stride I have given as 1, padding I have given as 1. So in mathematical calculation, you might have seen how exactly the strides works, padding works, etc. Right? So padding basically means with the matrix of all the pixel value, another padding layer would be added, whether it might be 0 or whether it might be 1. Based on that, calculation would be performed. Stride means based on two different values, another extra strides will be added, and a mathematical calculation would be taken forwarded. Okay, then after that, I'm applying the max pool here. And what is the size I'm giving? I'm just giving the size of 2 comma 2. Okay, two rows and two columns, that is the size what I'm just giving for a simple sequential model. You can also change the sequential model if you want, or the values. Okay, later on, after the completion of this, you can just try it. Okay, so after building the sequential model here, so what I'm just trying to do here, I'm just creating a for loop in order to apply this. Okay, so I'm just taking the images and the labels for in the training DL, the entire data set where it was available. Okay, and I'm just applying the simple model. And what is the simple model? Simple model is nothing but the sequential model. Okay, and these are the size of the torch tenses what I'm using: 128 comma 8 comma 16 comma 16, the image size. Okay, then So later what I'll be doing is I'll just build a certain class. If you want to do the manual things, you can also do this. But what I have done, if you want to build the manual function, you can also do that. That is also one way in order to work it. But I'm just created a certain class in order to do it in a single code cell. Okay. The class what I'm just keeping is image classification base. That is the class name what I'm giving. Okay, where I'm passing the neural network module, NN module. I can just give whatever the neural network module I want. Okay. Then first function, I'm just giving the training step where I'm just defining the batch size, images, everything. Okay. Then later, see here in this certain function, we have already, I have highlighted what exactly this function does. I have added a comment here. Okay. It generates the prediction and it also calculates the loss. Okay. Now in the second function, the validation step, it generates the prediction, calculate the loss, and it calculates the accuracy as well. This is the validation step. This is the training step, and this is the validation step. Okay. Now here I'm just creating the epochs here, where I'm combining the losses and combining the accuracies. Okay. Then later on, I'm calling out the function to check out the accuracy and to check out the epochs as well. The function got executed. Now, what I'm doing, I'm just building a layer now. Okay. What you can just tell that I'm building an architecture now, neural network architecture. Okay. I'm constructing here with a sequential model. Just have a look. I'm building a sequential model where I'm using convolutional 2D and I'm using ReLU. What is this ReLU? ReLU is nothing but rectified linear unit, right? And why exactly it is used? It is one of the activation function. See, if you remember in neural network, uh, sorry, just a minute. There's something stuck here. Guys, just give me 1 minute, okay? Just 1 minute. Right. Okay. Let me just reshare the screen. Right. Where exactly I was? Okay. ReLU. So ReLU is nothing but rectified linear unit, one of the activation function. So if there are neural networks, if there are neurons which are available uh, in by collecting some inputs, if you need to activate that neuron, so you have to be using activation function. So there are different activation functions you can refer. We have ReLU, we have ELU, we have pre-ReLU, right? A lot of different activation functions are there. So each activation function plays a different what mathematical calculation. You can just explore that one. Then again, I'm creating another layer with convolutional 2D with 32 of 62 and adding the strides, padding function, etc. Then again, after applying that layer, again, I have added the relay activation function for that one as well. Then for the I have applied the max pull uh, of 2 comma 2 here. Done. Then later again, you can see these are the different uh, what layers what I'm just creating. I can create as much as possible. where I'm just if you have gone through the neural network architecture, you can see like how exactly multiple neurons will be created, and then how you have to flatten the neurons. Then for final thing, how you have to make it as a sigmoid activation. Okay, sigmoid if you have only two outcomes, but here we don't have two outcomes, we have multiple outcomes, right? So you cannot use sigmoid here. Okay, so likewise you can just build the layers here. So multiple layers has been added here with flattened layer, with linear layer, right? Where I'm just extracting the size till 512 and with 10. Okay, so let me just execute this function as well, right? Then let me just check the model summary here. This is my model, CFAR10 CNN model. This is the summary. Okay. Then again, you can just check out the size or the shape, whatever you have. Right. Now, if you're using CPU or if you're using GPU, you have different things where you can just execute and you can just start iterating uh, for the training part. Okay. So if you have the GPU, you can use it, or you can just stick with CPU only. Okay. So if you have CUDA, that is nothing but GPU. It will work on that GPU system, or else it can directly work on CPU as well. Okay. So multiple functions I'm just creating for that one as well. Okay. Then device data loader also. I'm just using creating a function where I can just start moving the data after a certain device from one to another. Okay. Yes. Now my device is nothing but CPU. You can just have a look. You can also try it if you want. Okay. Right. Now here the training the model, evaluation, and the fitting of the epochs, like how much you want. You can just go through here. I'm just using the SJD regressor for optimization process. Okay. So to fit this, I have to pass the epochs, the learning rate. These are the things what we had learned in the last session as well. Okay, if you remember that for linear regression model also, uh, we have to be passing very minimal value, that is 10 power minus 5. Then model name, train data, or validation loader, or optimization method, etc. Okay, so let me just execute it, and let me just give the data set here with the device, and let's start evaluation here. The model plus the validation data set. Okay, now this is the validation loss and this is the validation accuracy. Okay, now let me just give the epochs as 10 as of now. Okay, 10 epochs, that means 10 iterations. Okay, so I'm just giving number of epochs as 10. Then optimizer I'm just giving as Adam optimizer with the learning rate is 0.001. If you remember, for last week I had given 0.0005 something. Okay, but this time I'm just giving the learning rate 0.001. Okay, these are the values what I'm just passing, and let me just define the accuracy, how exactly it is going based on the epochs. Okay, so you can see that accuracy got increased as the number of epochs were increased, but for the epoch numbers 7, okay, there was a downfall for the accuracy. Again, for the epoch number 8, there was a increase again. Okay, so this is just only for 10 epochs, right? So we have displayed only for 10 epochs. Let us make it for 20 as well, not a problem in that. It's gonna take some time. Let me just train it here. This time I'm using 20 epochs. I will wait until the training phase gets completed, the epochs, the iterations. You can give the learning rate as 0.0005 as well. Uh, Less smaller this thing. Right. Yes, even though the data set is quite little big, and what we tell, as of now, I'm using CPU. It may take some time. It may take some while. Okay. Let's just go with other different code cells. Okay. That was the reason I had not executed this. But yeah. Okay. Then here we have just plotting the accuracy in terms of charts rather than displaying the numbers. You can also check out the numbers here, or you can just show the plot. By showing the plot, you can just observe it much better. Okay. Just have a look from epoch number one, how exactly the accuracy is getting increased. Epoch 1 is not sufficient, or even 10 is not sufficient. You need to still provide multiple epochs so that training can be done much better. For second epoch, the accuracy was about 60%. Then later it got increased, decreased again, and got increased. Okay. And here you can also cross check with the training and the validation, the loss here, the loss function with the number of epochs. So here you can just have a look where exactly your validation epoch is stopping at a certain point. Okay. So your training error is going beyond like after the epoch number 3 or 4, but it would be great if you just stop somewhere here for the epoch number 6 or something, because it is going constantly lower. It is not going too deep, but it is sticking somewhere here. You can stick with epoch number six to get the better result. Okay, just refer this certain graph in order to understand. Right. Then what else is left? Then you are just testing with the individual images here. Okay. Still the code cell is getting executed in the fitting part, because I've executed for the 20 epochs. Not a single epoch has been trained yet. Okay. Uh, you might be aware about overfitting, right? You can just go through those concepts as well, overfitting, underfitting, and all. Okay. Then you are testing the image for the test image here. So I've created a function where it can just take the info from the model, and from there it can just predict. Okay. So randomly I have provided the image here. The actual label is airplane, and the predicted value is also airplane along with the image. You can just check with some other images. Actual image is automobile, and the predicted image is also automobile. Here, actual image was frog, and predicted image is also frog. Okay, here there was a slight error here because we had not reached the maximum accuracy. Here, the actual image is of horse, but the prediction we are getting as a deer, right? Because the species looks same, it's quite closer. Okay, but the accuracy was somewhere around 78 or 79 or something. It is giving the wrong prediction. That is why I just increased the epochs up to 20 now this time. Let's see like how can we get the output later on. Here the actual image is of horse, and the predicted is also horse here. Okay, still the training process is going on, and it may take a while again, I guess. Okay, so in the meanwhile, let me just share this file with you people. I would request you to download this file first and try it in your drive. Don't execute in the same code cell file here, okay? Because this is the file what I have shared it. So you can just download it and you can just start focusing on it. And give me the confirmation if you are able to upload or load the file in the collab. I've shared the link. You can click on the link and then you can just execute that. I've shared the link. File in the sense the link what I've shared. Uh, okay, sorry, my mistake. The message is being shared to host, I guess. Sorry, my mistake. Again, I have shared the link. Everyone cross check. This is the link. And you can just test it out. Okay. My system did not had that capability to execute this time because of slight internet issue, I guess. Not a problem, but anyhow, you can just test it. If you people have the GPU, that is well and good. Or else you can also change the runtime here. Okay. So what you can just do is click on runtime in Collab here. Okay. Just search it for change runtime. Instead of CPU, make it as T4 GPU. Okay, it will work more efficiently. It will work more faster. The epochs will be trained much faster way. That is also one of the additional source we can tell. Okay. So this was all about the CFA dataset. So this is just one example. If you start building your own CNN model with the help of PyTorch, you can just take any data set from the online sources, or you can just do the manual survey and you can start building your CNN model with the help of PyTorch. Any doubts still here? Is everything clear till here? All good till here? See, one or two is responding, it's totally fine, but I'm still expecting from others as well. Right. Great. Right. Mm. Okay. So previously, I think we had stopped somewhere in just a minute. Generative AI, I believe. Right. Just 1 minute. Okay, I'm sharing the screen. Okay. So shall we go with the next things now? Yes, Jit, you can select T4 GPU runtime. Yes, you can use. Even though you are using CPU, you can use T4 GPU because it is much faster compared to the CPU. Yes, so that you can have a what faster computation. You can use. All right. Shall we go with the next things now? I want the confirmation from your side. I know that I have shared a file right now, but I would request everyone to stop that one. You can just do it like by EOD, I believe. Uh, After your session gets completed, you can start working on that project part, the CNN project, what I have shared. Right now, if you just pay attention into the technical content here, that would be great. Okay, right. Fine. Okay. In the last session, again, we had started with generative AI. So can I just get the major definition about this generative AI? What exactly is this generative AI? Previously, we also checked what are the different tools are available in order to work with the images or it order to work with audio clips, video clips, text to text, image to text, etc. Right? So likewise, we can also go with other stuff. Okay. So let's talk about LLM models here first. Okay. So LLM stands for large language models. And we also call it as these are nothing but the foundation models. Okay. LLMs means large language models, and we also call it as these are nothing but the foundation models. These are the foundation models or the pre-trained models. Okay. Training is not required again and again. It's already trained from the historical facts, from the historical data. It is already been trained. Okay. So how exactly it is been trained? It has been trained on massive or enormous data sets. Okay. Now these are the different systems which has been trained on the huge number of data sets or multiple enormous amount of data sets. Now, what are their capabilities? Now, it has the capability of understanding the situation. It has the ability to create or generate a text. It can also understand the natural language, whatever the things you provide. Right? You can take any example, whether it might be ChatGPT, whether it might be Copilot, whether it might be Meta AI, right? So you can just write anything. If you just type it in Hindi, your LLM models will be able to understand the Hindi, and the output also you can just get it from Hindi only, because it is been trained on different natural languages as well. Okay, you want to try it in Malayalam, just give the text in Malayalam, you can expect the output from Malayalam as well. Okay. Now, why exactly it is used? It is used to create the content. It will help as a virtual assistant, creative writing. It will help you to code. It will help you to debug the errors. Lot of things is been possible. This is what large language models are. Okay. Now let us see how the formation started, the evolution started for these large language models. Okay. So in the given image, you can just have a look. In the year 2017, the first thing came as transformers. Okay. So transformer is one of the machine learning architecture. Okay. And there is a research paper, like even last week I had told, I guess, that is the research paper called as Attention is All You Need. Okay, you can refer that a research paper. Attention is all you need. So what exactly it does? If you just provide a certain sentence, hello, how are you? So basically, each and every word will be what split, and it will be converted into the numbers, and it will try to relate how exactly it has to give the priority for each and everything. Okay. Now this transformer is one of the neural network architecture. You have to understand this. Okay. Majorly for performing some NLP task. NLP, again, this is nothing but natural language processing. Okay, if you want more detailed inputs about this transformer architecture, you can just go through that research paper, what I have already told. Attention is all you need. Okay, now why exactly you require this? Because it has the mechanism where it can understand the entire sentence. Rather than reading the words one by one, it can understand the sentence, and it can try to relate where exactly it has to be used. That word where exactly it has to be used. Okay. Then after the transformer architecture came, then again in the year 2018, GPT model came. Now what is this GPT? GPT is nothing but generative pre-trained transformer. Now again, this is also one of the transformer. It is telling generative pre-trained transformer. Okay. So who released this GPT? This GPT has been released with uh, the company called OpenAI. Okay, and that is in the year 2018. Okay, then again in the same year 2018, there is another thing came called as BERT. Okay, so BERT means again it is also one of the transformer model. You can see whenever it is coming called T at the last, that means it is also one of the transformer again. Okay, so BERT stands for bidirectional encoder representation for the transformers. Okay, now it was developed by Google. See, GPT was developed from OpenAI, right? So OpenAI is not only one of the AI company. There are other AI companies as well, right? And Google also have the tough competition, right? And what they have developed one of the language model called as BERT again. Okay, again the same things what we perform, that is nothing but NLP kind of things. NLP task can be what done over here. Then after that in 2019 Feb again GPT the second version came, GPT-2, generative pre-trained transformer, the version 2. Again after that T5 model came. Okay, now can you tell me is anyone aware about this T5 model, who have heard about this T5 model? Again it is also one of the transformer model only, T5. I believe like few people might have heard about this. Okay, now see, likewise GPT and BERT, again T5 model also works on NLP, what problem statement, text to text problems. Okay, if you are providing some text, based on that text you can get the output in the form of text only. Okay, it can do some translation, it can do some summarization, question answering system, etc. So this again T5 model also works the same. Then later on, sorry, later we got GPT-3 from OpenAI again, where there was a certain benchmark with a lot of improvement, right? Then again later we had Flan model also from different company. Okay, yes, Flan also you can just refer as it is one of the open source. Okay, where it had the benefits of fine-tuned encoder decoder. And who released this Flan model? Again, Google. Likewise, BERT, after the improvements of it, like Google released this Flan again. Okay. Then March 2022, Instruct GPT came, that is GPT 3.5. Then later 2022, November only, we got ChatGPT. Then 2023, there was a Llama model. Llama again. Who gave this Llama model? Meta, right? So in Facebook we are using sorry, in WhatsApp we are using Meta AI, right? So Meta AI is using one of the language model called as Llama. Then again 2023 March we had GPT version 4, 4.0, Llama 3.1 with 405 billion parameters in 2024. Okay, OpenAI with 01, DeepSeek came, DeepSeek with R1 came in 2025. Okay, and this is how the things came towards the LLM series. Okay, so apart from this, there are other different companies which is having their own LLM models, like Microsoft have the Phi series, PHI series, right? Then again, Google have the Gemini series. Then if you are talking about different other companies, IBM have IBM Granite models, Granite series. Likewise, there are different companies in the markets as well. Okay, right. Okay. Now, when we are talking about the applications, there are major applications where exactly we use this JIT BERT is nothing but bidirectional encoded with transformer. It is from Google. Just now I just told about the BERT, where it can perform NLP task. No, BERT is not from OpenAI. It is from Google. Okay. Don't get confused. You can just do some research and get clarified. Okay. All right. Okay, applications of LLM. Here we have a lot of different tasks what these LLMs can perform. Sales automation. Okay, so if you have the sales report, like it's gonna create some report for us, right? So you can take the example of the BI things, BI tools. So whether it might be Power BI from Microsoft, Tableau is there, ClickView is there. So directly what happens, like if you just provide some raw data, based on that, it's gonna give you the patterns of the data, not the patterns, the insights of the data along with the representation from the charts or the graph. Okay. Storytelling. Yes, from that sales data again, the storytelling can be generated. It can generate the story like why exactly this much profit was there, or what is the total sale of that certain month, and what exactly made that month more profitable or the loss, everything. Then again, candidate screening after hiring process. These are the major things. Like it can screen the candidate by understanding its thing. Transcription, it can prevent cyber attacks. These are some real world application. Sentiment analysis, it can understand your sentiment, whether you are angry, whether you are in a bad mood, or whether you are happy, right? So whatever the text you pass to the LLM models, it have the ability where it can understand your mood swings as well, your sentiments, we can say. Code generation. Yes, code generation basically means that if you want to build a web page, if you just seek the help, whether it might be GitHub Copilot, whether it might be ChatGPT, or whether it might be File series from Microsoft, you'll be able to generate the code. Okay, majorly for code generation, if you remember in the last session we discussed, one is GitHub Copilot and one was ChatGPT, right? Then translation is, it has the ability to focus on multiple different languages, whether it might be French, Spanish, English, Hindi, Kannada, whatever the languages you want, you can just translate it. It have multilingual languages support. Okay. Content generation, it can generate the article for you, it can generate the uh, what AI generated content. A lot of things are there. Again, virtual assistant, you can create a certain LLM integrated with the chatbot, where your chatbot can give AI generated response by having the access with the LLM models as well. So these are quite few real time applications. Okay. Now, how exactly this LLM works? There is a mathematical what structure behind it in the background. Okay. Prompts or inputs. What is this prompts? Basically, a user is entering a query. Okay, if the user is entering a query, what happens? That is considered as a prompt, or you can also see few people will also call it as inputs. Okay, the second thing, how LLMs work, tokenization of the inputs. Okay, each one of the word, it will be tokenized, which means it will be split accordingly to the tokens. Then multiple different calculations would be performed. Embedding layers will be there. In the embedding layers, again, encoders, decoders will come. Okay, encoders where it will have some mathematical calculation where it takes the input, and decoders, it will try to give you the context. Okay, so all these things will be given in the form of output, whether it might be articles. If you just give the text, it can give the article for you, lyrics, image, code, songs, poetry, etc. Okay, now again, there are different kinds of what we tell responses. Okay, so one of the responses, straightforward, see, fact-based answers. Fact-based answers is like giving a straightforward answer. Suppose if you are asking a question, what is the capital of France? Only one line answer you will be getting. Whether what exactly is the capital of India? It's nothing but Delhi, right? So likewise, only the fact-based answers will be provided. Okay, there's another type of response called as decision making. Okay, so in decision making, what happens? Basically, multiple strategies will be there. Okay, in order to achieve a certain goal, you'll be asking to the LLM model, this is my scenario, and I'm stuck somewhere here and I need to achieve that goal. Okay, let's consider a simple example. Imagine that you're standing in the road and you want to travel from that position to the airport. Okay, so imagine you are stuck somewhere uh, inside the city called Delhi, and you want to go to a Delhi airport. Okay, so what you'll do, you'll just open the maps and you'll just give the pickup location. You'll select your location first and you'll give the drop location. Now, what happens? The map will give you the different transport routes. You can just take two-wheeler, you can just take four-wheeler. There are public transport and different things also will be highlighted, right? Like what is the duration you will take. If you are taking the public transport, these are the minutes and this is the time, hours which required. If you take two-wheeler, how long it may take. If you take four-wheeler, how long it may take. So these are the decision-making prompts as well. Like, okay. Then there are another type of prompts where it analyzes the trends in the market. Okay. So if you just provide the raw data, again, like it will try to understand the patterns. It will try to give the trends. Okay. In which month there will be a high number of sales, or when exactly you need to give the what discounts if the sale is low. You can understand all those trends by providing the data to the LLM models. There are other types of responses. One is recommendations, summarization, translation, etc. So, recommendation, personalized suggestions. You might have seen that if you are interested in a category, that same category will be recommended, whether it might be the social media sites or different things. If you like cricket more, often you'll get all the reels related to all the feeds related to cricket itself. Okay, so this is how AI generated recommendations can be taken out. Okay, again with the summarization, if you just provide the lengthy text, it's gonna summarize or it's gonna concise the summary and it's gonna give the article for you. Again, one more type of response is nothing but the translation, which plays a major role. Okay, so translation it can have the access for multiple different languages. So these are the different types of responses what you can get it from every different aspects. Okay, right. Is everything clear till here? Any doubts? Clear. Great to hear. Right. Okay. So there are few more things what we'll be discussing. See, majorly what we require is we want to work on Copilot as well. Okay. So in Wednesday session we'll be exploring why exactly we use Copilot, why exactly we require AI agents, right? So let's understand what exactly this AI agent is. Okay. So is anyone aware like what is AI agent? Why exactly it is used and how exactly AI agent can help us. Okay, can I get the count like how many are aware about agentic AI? Can I get the count? How many are aware about agentic AI? See, if you're not aware, you can just put no. Not a problem in that. If you just give the response accordingly, I can just explain you about agentic AI and AI agents, etc. There are different agents so that we can just understand like how these agents are working. Okay, so many people are not aware about agent AI as well. Okay, so let's just start with a basic concept called AI agent. Okay, so we'll just start with very basic AI agent. Now, what is this AI agent? AI agent is nothing but a software program that can take decision on its own to achieve a goal. Okay, so imagine that you want to achieve a certain goal. In order to achieve the certain goal, your AI agent will help you to complete the task step by step. Okay. Now, what are the capabilities of this agent? Sorry, AI agent. See, AI agent is different and agent AI is different. There is a slight difference here. By end of the session, you will be able to understand agent AI and AI agent. Okay. So this AI agent, it has the ability of observing each and everything. It can think, it can act, and it also learns. This is an AI agent. Okay. Now let's consider with one simple example. Okay. That example is nothing but imagine that you want to what you want to plan a trip. Let's consider one of the city called Pune or Mumbai. You want to plan a trip for 3 days from one of the region, Delhi or somewhere. Okay. And if we just give the prompt to the AI agent, it will start analyzing it. That's nothing, but it is observing your requirement. Okay. So it is understanding your requirement. It is thinking like where exactly you are and what are the different things are available, everything. Okay. How many days you are trying to plan a trip, everything you observe. The second part is he starts thinking of it. He has the thinking ability. Okay. So thinking ability in a sense, like it will start exploring the options for you. Can you take the flight, or you want to take the train, or you need to take bus, or it will also give if you are going by a road, by a car, like how much distance it requires. Okay. It will start thinking, and after reaching there, what are the different places you need to explore? What are the different areas you can just go? Everything it will start exploring. It will start thinking of it. Then after thinking, it will start acting to it. That means imagine that you have given a trip that you want to go by train. Okay. So it will give you the flight details. Okay. Sorry. If you want to plan it by a train, it will give the train details. These are the different trains which are available from Delhi to Mumbai, and this is the direct train, and these are the trains and everything it will give. And what are the nearby hotels are there, or the restaurants are there with the great ratings, everything it will give. And based on the experience, it will start learning that patterns. If you have the bad experience at that location, if you have the bad experience at that hotel, okay, it's not gonna recommend it, it's gonna improvise. It will start searching the reviews. It will start understanding what is the problem you have faced, or with whom you have traveled. It will start understanding your situation. If you are going with a family, what exact what problem you have faced with the family, each and everything, your agent will start understanding it. Okay. Now, these are the major things why exactly you use AI agents here. Saving time is one of the best benefit. You can just take one example. See, if you want to plan a trip in Google, will you put each and everything right now? No, right now. Nowadays completely relying on the agents only. So I'll just randomize text to the LLM model stating that I want to plan a trip for 3 days for this region. Okay. So it will give me the different plan what are the availability is there, whether it might be the train, facility on the flight, or what are extra things. Rather than manually searching in the Google or the browser, it will give you all the things in a single shot. Okay. It is easy to build, reducing the cost, providing proper accuracy. It has the ability of 24/7 AI agents, making real-time decisions, hyper-personalizing, you can just personalize based on your environment. It increases the productivity. Okay. So these are the highly benefited areas by exactly use AI agents. Okay. Now let us see how exactly this AI agent works. Now, once the user is providing the input, okay. Now that input will be coming under the agent with performing some autonomous action, which means it will start following up with each and every factor. Okay. Now what that agent will do, it has that memory, it has the activity button, it has the task where it can handle every situation, and it also has the external tools like API call, access to internet, right? It can also interpret code, large language models, accessibility, sensors and IoT devices, etc. Okay. So in API code, what happens? The agent has the ability when it can go to the different websites and upload evidence, how the user's response was, how the review was from the person. Okay. Second thing, it has also the internet access. It can directly browse the information from the web server. We call it as retrieval augmented generation. Okay. So it is retrieving the information from the browser and it is storing it. Okay. It has the ability of the coding. Okay. It can also interpret the code. Then again, large language model from the pre-trained model, it can also take some inputs. It also takes the inputs from automation platforms, sensors, and IoT devices, etc. Okay. From that, it can store all the information in the memory. It can also go under the activity where it can transfer all the useful criteria to the environment. Basically, environment is nothing but to the final output to the user. Okay. And likewise, it can perform all the autonomous action again and again. Whatever the input is having, that input will come under the autonomous action, and that action will be checking the results what we have provided. If there is any improvement left, like again that information will be fed to the agent, and again it will start improvising. Okay. So that is how your AI agent will work. Okay. Now we are left out with agentic AI system, and from the agentic AI, we have to explore what we can tell Copilot. Okay. So we'll try to relate this agentic AI and Copilot in the next coming session. That's on Wednesday. Now, as I know, I request everyone to go through that collab file, so that if you have any such doubts, so that I can just clarify right away. Let me just share the screen. Right. This is okay. So I request everyone to change the parameters and try it from your side and see whether you are able to run the epochs. Okay. So before running the epochs, I would request everyone to click on runtime and in the change runtime option, make it as 34 GPU and click on this. You can have a look. The changes will be displayed here. Now it is telling correct hosted runtime, that is nothing but T4. The runtime is being changed, where it will work much faster way. Link I have already shared in the chat box now. Okay, let me just reshare it. Okay, I have reshared the link again, so I want everyone to use this certain project and start exploring it. Okay. Even though I have changed the runtime, let me just try to execute the code once again. First, I'm importing all the required libraries. These are the libraries what I'm using, project ID, and here downloading the data set. Okay. So in the left hand side also you can just have a look at the folder which has been created, that is cfr10.bgz. So if you double click on it, that can also get downloaded into your operating system. As of now, I'll just stop that one. Here. Okay, the file size is containing as 129 MB. The referred details is totally different. So it was showing as 51.5 MB per second because I had extracted the file, right? So you can see even though it is a zip file, it is showing 129 MB. So if I just unzip it, it will be much more than that. Okay, right. Then later what we are doing, we are just extracting the tar file here. Simply we can tell that we are compressing. Then we are just checking all the classes. Okay. So there are two different folders, train and test, and these are the different 10 classes which is available in the dataset. Here I can just check a certain folder what are the different images are coming. So this time I have given as bird. You can also cross verify. If you want to check 10 different images, you can just pass as 10, 15 based on your requirement. Okay, so I have given the index position as 15, or I can make it as 10 as well. Okay, then one more label of the ship, you can just test it out. Right. Then we have Torch Vision where we are importing the image folder and where we are just transforming all the images into the tensors. Executed. Then converting all the images to the tensor and storing the inputs in the data set. Right. Then this is how we are just checking all the tensors. We are checking the classes of the data sets where we had stored the tensor values. Whatever the inputs were there, the same thing is available in the data set as well. Later, we used matplotlib library in order to yes, Pratik, we'll be having hands-on with Copilot. Yes, we'll be having the hands-on. We'll be having the project part in Copilot. We'll see what are the different tasks this Copilot can do, right? It's not only that key we'll go only with the theory, we'll be able to create the agent as well. Okay, as of now, just focus in this project. Later, you can just work on Copilot. Okay, here we are just defining a image, defining a function to open the image. These are the sample images where we are loading. Training validation. Here we have created a grid image. See, each and every time you execute this, you'll get different images. The grids would be changed. The kernels and into the tensors, then the pooling layers will come, neural network and sequential model which you have created. Then the training size. We have built a class called image classification base. Then another class called CFAR10 CNN model. And this is the model name, CFAR10 CNN model. Okay, right. To check with the GPUs and CPUs. then connecting with the device. Okay, this time it is coming as CUDA. Now training the model. Let us see the evaluation, validation, loss, and accuracy. Okay. Let me make it as number of epochs as 20 and start executing the epochs here. So in order to execute the epochs, you can just use fit, number of epochs, learning rate, model, training data, validation data, and the optimization function, which we have already given. See, all this started. So this is epoch 0, the training loss we are getting now. Previously, it was showing very late. It was executing little slow. As of now, I have changed it to T4. Uh, the process got started. Just have a look. Much faster. We'll wait until all the 20 epochs gets completed. Then later we can just check it out. So it's not mandatory that you have to use only 20 epochs. How do we select the epochs? Based on the training error and the validation error, or the loss, you can tell. Training loss and the validation loss, based on the comparison of both the things, you'll be selecting that one. You can just give it as 10 epochs for your case in order to execute this. You can see after each one of the epoch, the uh, loss is getting lowered here, right? So the in the first epoch, there was a loss for the training that is 1.769, 1.2, later it got to decimal, 7,654. It's going less and less and less, the training loss. See, if you are focusing only on the training loss, it will be overfitting. That means for training accuracy, you will be getting very high. Training accuracy will be very high, and your validation accuracy or the testing accuracy will be very low. You cannot only rely on to the epochs. Based on the training loss and the validation, majorly based on the validation loss, you will be selecting how much amount of epochs you have to be using, not on the training loss. That thing you have to keep in mind. After trying it, like, you can just tell me which is the best validation epoch which you can keep it. Yes, exactly, Path. You can see that in the validation loss, the loss, once it was started decreasing, again slowly it has started increasing as well. Okay, just have a look. Like, we had a validation loss here, 1.4, 1.1, 9, 8, 7, 6, 7. After the epoch called 6, it have started losing the accuracy here, validation accuracy. Training accuracy is getting lowered, but we are not focusing on the training accuracy, because if we are focusing only on the training accuracy, it will be like overfitting. The model will be overfit. Okay, you have to stop at a certain point where the validation accuracy starts getting increased after decreasing it. So you can stick till the epoch number 6, that is 0.7. That is the validation loss. And soon after that, you can see that it have started increasing. 0.75, 0.81, 0.88. Either you can go ahead with epoch 6 or 7 max. Okay. So here it have started increasing. So you cannot completely rely on to the number of epochs. Only training the model with the training set is not a good idea. You have to be cross-checking the validation as well. That is what we have displayed here. Here, validation accuracy and the training accuracy. I have used 20 epochs, right? The diagram also will be changed. The graph will be changed. Just a minute. Let it get executed. Then we can just try it out. Yes, all the 20 epochs got completed. Now just check out this plot here. Here, based on the accuracy, how exactly you're getting. Even though you are getting the accuracy, but accuracy is not only the factor. The this thing, epochs and the loss will get increased here. Here you can just check. See, this red color one is the uh, validation loss here. So once the loss got decreased till here, somewhere around 6, okay, 6 or 7, we can consider here 6, right? So soon after this, like what happened again, it started increasing. We have to stop to a certain point, which is getting lowered here. For here, the validation loss is coming very low. That means we can stop for this certain epoch. Okay. So the epoch number 6 is more sufficient for our training so that we can get a better result here. Now this model got overfit. Overfit in the sense for the training data it will perform very well. But for the testing it will not perform that good. Let's just try. So here the actual label is horse and predicted value is deer, right? So if I just execute here, okay, I need to run this. All right. Right. Now just have a look. So previously it was giving a correct output for me because it was not overfit. Now this time my model is overfit. Now this time the label is airplane. The output I'm getting is ship, which is not proper. Let's try for second image. Automobile is totally fine. Frog is also fine. Again this horse and deer. It's not a good sign. Horse and a horse, right? So for this first image only, you can see it was an airplane. Previously with the lower epoch, it was suggesting a good accuracy. It was predicted that it is an airplane only. This time it is telling us it is a ship. Okay, so that is how the thing gets changed when you are not utilizing a proper epoch number. Along with the model training, you should be very careful while giving the hyperparameters. When exactly to stop and when exactly or what exactly the epoch number you have to be using. Okay. I believe everyone have executed this uh, project, CNN. Can I get the confirmation in the chat box? Like how many have successfully executed this? Okay, Yuvraj. Only Yuvraj? I'm still expecting from others as well. Right. Dhruv, okay. Yes, great. Great to see people are responding you. Others who have not yet started, I would request you to start exploring the things. Done. Done. Any doubt till here? So you can just tell which data set you can just use apart from this. You can also try with hand digit recognition, handwritten digit recognition. Even that is also one of the good data set where you can just have a practice. There was another data set called as Fashion MNIST or something. You can also try that one. Fashion MNIST. I'm not really sure. Yeah, where it had somewhere around 60-70,000 images again in that one as well. This is the RGB, and that fashion MNIST is nothing but the grayscale images. That is the thing. Any doubts still here? If you have doubts, you can just ask the doubts in the chat box. We have 5 more minutes for the discussion. No doubts. Okay. Want to connect with me regarding the project? Yeah, sure. You can just take my LinkedIn ID if you want. You can just search it for, let me just share my LinkedIn profile. Yeah, you can use this. So we'll be having other set of concepts like how to create the different agents, how to work on Copilot, etc. And later we'll be having the Azure concepts as well in upcoming days. Okay. So you can take a lunch